So for this question, if I make this coordinate and just put a square loop like this, and this side of this loop is L, and there is a magnetic field which is in x cap, y cap and z cap direction. So we know that if I want to calculate the EMF, the magnitude of the EMF will be given by d phi b upon dt. Okay? The magnitude of the EMF is given by this. So obviously we have to calculate the magnetic flux. Okay? And magnetic flux will be this is x, this is y. So let us take it in z cap direction. So B dot A. So a small magnetic flux will be given by B dot dA, and that will be equal to, so dA is in z cap direction, so only this much will survive, B naught beta naught 3y square t, and dA will be dx dy, because this is xy plane, so a small area here will be dx dy. Okay, so if I want to calculate the magnetic flux, it will be given by B naught 3t integral y square dy into integral dx. Okay, so this will become beta naught 3t, this will be L cube by 3, and this will be L. So it will be 3 and 3 cancel, it will be beta naught L to the power 4 into t. Now this EMF is given by d phi by dt, so it will be beta naught L to the power 4. So this is direct question on Faraday's law. This is a question on Faraday's law. You can see just a non-uniform magnetic field was there. So magnetic flux should be calculated using the integral because of the non-uniform magnetic field. Okay, area vector you already know. Just take the dot product and just the derivative. Okay, clear?